Thank you. I will appreciate you having me virtually here. So thank you everybody for jumping on. And as Jeff said, yeah, so I work on the residential side of Lutron's business, focused on Ketra, so our full spectrum lighting control, and have been working with Lutron for about 7 years, based out of the Bay Area in California, and I definitely want to walk everybody through the well building standard and kind of how lighting plays a role in designing and getting a certified well building. So definitely feel free to ask questions throughout, and we can monitor the chat. Otherwise, we'll save some time at the end as well. So what are the objectives here? So what are we trying to learn is really what is the purpose and the structure of the well building standard V1. So we'll talk a little bit about V2, which is out now, essentially as of 2020, there is well standard version 2. We're going to look at the good, better, and best options to meet the light features, so the light requirements. We'll talk a little bit about circadian lighting and how circadian lighting plays into well buildings. We'll talk about electric light control, daylight control through windows and automated window treatments, and then various strategies that kind of meet our glare control requirements and the automated shading and dimming controls for standard 1. And then also we'll look at a little bit of a case study with the ASID headquarters in Washington, D.C., and see how they were able to achieve certification. So what is the well building standard? It's a good idea to just kind of define what we're talking about here. So it's a performance-based system that measures the impact of the built environment on human health and well-being. Really, it's an all-encompassing sort of solution for creating intelligent spaces that really take the occupants of the space into mind, as far as everything from lighting, shading, which we'll talk about with natural light, even down to things like air quality, nutrition. Really, it's a pretty truly, all-encompassing sort of solution and system designed to really create, again, safe but also intelligent spaces that think about their occupants. And it's been grounded in a ton of research from medical experts, designers, and people from the industry itself. So why pursue well certification? So people are the biggest cost when we think about businesses. Let's say specifically is the amount of money they spend on utilities is maybe $3 a square foot, $30 a square foot on rent, but the amount of people cost is 10 times that, right? So there's a huge investment that businesses make in their people, making them happy and productive, and everything else is going to be a top priority to ensure kind of the longevity and sustainability of a particular corporation or business. So if we kind of follow these standards, which are designed with the occupants in mind, we can really generate results and have happier people, and happier people tend to produce better results as is anyway. So how do we get there? Effective lighting and daylighting are both huge energy costs, but they're also people costs as well. And we've all probably been in projects or been in offices or restaurants or whatever that have quite terrible lighting, and it doesn't make you feel great or look great. And so we'll kind of talk a little bit about how that all plays into well. So who created the well standard? It was created in collaboration with Delos. After 7 years of research, they collaborated again with doctors, scientists, and kind of came up with this standard. And then it's also administered by the Well Building Institute, and they're trying constantly to improve human health and well-being through the built environment. And then also with GBCI, the Green Business Certification Incorporated, which is going to master and worry about LEED certification and provide third-party certification for well as well. So it's kind of this collaboration between these different entities, which is what got us to where we are. So there's a few different types of well projects. So the first is going to be new and existing buildings. And we talk about new and existing buildings, that's the full scope of the project design and construction, and also aspects of building operations. We also have the new and existing interiors certification, which is going to apply to commercial interior projects in new and existing buildings. And then the well core and shell certification. So that's for projects looking to implement fundamental features to the base building for the benefit of future tenants. And it looks at things like building structure, window locations and glazing, building proportions, HVAC, water quality, site location. Today, what we're really going to focus on is going to be the new and existing building requirements. So what we're going to do is take a look at what goes into that, what categories are there. So I mentioned this earlier, but it's not just light, right? It's things like air quality, and that has become ever more prescient in recent months. Obviously, a lot of this stuff is kind of taken on new meanings as we've been living in this kind of 2020 sort of world. So thinking about things like filtration, ventilation on the air side, clean water for occupants, nourishment. So, things like healthy food, thermal comfort. So making sure people are comfortable from a temperature standpoint on the HVAC side, even on things like mind, right? So making sure that the design, the technology, and the treatment strategies are all going to create a physical environment that optimizes cognitive performance and also emotional health as well. So it's really this full 360-degree view of what is it like to live and work in that building. If we're talking about office spaces, probably where you're spending 90% of your time, and you want to make sure that you're as comfortable there as you are at home. And now with things like home offices on the rise, taking into account a lot of these on the residential side has also been something which has been more and more relevant and kind of present this year specifically. There's categories for fitness, making sure that they're integrating exercise and fitness into everyday life. But what we really want to talk about today is going to be the light side of this. So what do we actually look at when we look at certification? So there's 3 different levels. You could be WELL Silver, Gold, and Platinum. To become Silver WELL certified, you just have to meet all of the preconditions. So we have preconditions and we have optimizations. The preconditions are going to be things that have to be met. Optimizations are going to be things that are kind of your nice to haves and good to haves, but they're not the base level requirements. So depending on how many of those preconditions you meet, that's where you get your different certification levels. So if you meet 40% of the optimizations, you then get Gold certification. If you get 80% of them, you get the highest level, which is Platinum. And when we talk about that ASID project, which is a Platinum certification, we'll talk about some of the optimizations that they met as well. So, we have to kind of look at those categories we just looked at, the fitness, the light, mental, everything like that, right? Making sure we hit all of the base level preconditions, which we'll talk about to be able to be certified. So what does the process look like if we wanted to get WELL certified? So the first thing is going to be registration through WELL Online. And then once you actually register, you're going to get a WELL assessor assigned to you. And then that assessor is going to compile the standard requirements and actually go do a documentation review and a performance verification. So they do want to look at all your documentation first, and then they're actually going to go and take some measurements and see how it's being implemented into the space. Once it passes the documentation review, it's going to then get that performance evaluation. And then once it goes through that process, it's then going to achieve certification. And then you would, again, recertify it to make sure that you maintain that same level of standards over time as well. So the WELL certification is going to be valid for 3 years, and then you would get recertified after that. Cost of registration, $1,500 to $10,000. It ranges pretty widely. Certification is going to be a minimum of $4,000. It's all going to be based off your square footage, and then the performance verification is about $9,000 minimum, and that's also based off square footage of the property. So let's talk about kind of our specialty here. So let's talk about light for a minute. So let's go back to lighting 101 here. So just kind of to get a sense of some of the terms that are going to be called out in the requirements, we want to know what we're looking at. So you'll see lumens called out. So the luminous flux, typically, if you were to look at lighting products, you'll see the lumens called out as far as the delivered lumens, which is how much light is actually going to emanate from the source, right? But what we are going to really look at is the illuminance side of things. So it's going to be measured in lux or foot candles. Just kind of it's a ratio between the two of them if you wanted to convert one to the other, but it's going to take into account what you're seeing that's actually hitting the surface. So when we talk about, let's say, an office space, it's going to be light that's hitting work desk, for instance, and it's going to take into account how much reflectivity that has as well. We'll talk about the reflective value, but just important to know when we talk about illuminance versus luminance and so forth, the terms can get kind of confusing. They sound very similar, but really when we're looking at lux and foot candles, we're talking about that illuminance, which is going to factor in the actual surface itself. Getting even more into the weeds here. So, light is part of the electromagnetic spectrum. It's visible light is right there in that sweet spot right in the middle, below infrared and above ultraviolet. It's just, again, kind of fun to look at some of this stuff as far as like defining the terms when we talk about what light is. So it's a whole range of electromagnetic radiation is going to be what we're looking at here, but we're really obviously focused on the visible light side of things. But light also factors in the biology, and we'll talk about that when we get into the circadian qualifications. So, you know, what is an eye made up of? It's, you know, rods, cones, and then these they call RGCs, and that's going to be how your eye and your body interprets light. So, just again, worth taking a look at some of the biology behind light as a concept. So circadian rhythms is probably something you may have heard of, you may have noticed in the past several years. Your phone may start shifting to become a warmer temperature in the evening, right? It kind of takes away some of that blue light. That's a kind of practical application for circadian rhythms, but what does this mean is we've kind of evolved as humans to work with the sun's natural cycle, right? The sun comes up in the morning, it goes down in the evening, and then we sleep at night, right? So as we start to wake up, we're going to start secreting, stop secreting rather, melatonin, which is going to be something, some people take it as a supplement. Your body will produce it naturally if you're, again, in an environment that caters to circadian rhythm, right? And then we're going to start to actually get more alertness as we go into the early morning towards noon hours. Fun fact, your fastest reaction time is going to be at 3:30, and then you're going to get into this stance where you're going to have your highest blood pressure in the evening, and then you're going to start secreting melatonin. So melatonin, is just kind of a fun fact, is it's not necessarily that melatonin makes you sleepy, but melatonin tells your body that it is evening, and it is essentially, for animals that are nocturnal, for instance, melatonin is going to tell them to wake up. For us, it tells us to, you know, start to get ready to go to sleep. But this is how our, you know, biological clock works. Fortunately, as we've kind of evolved to have artificial light and spend more of our time indoors, we've kind of gotten further and further away from this, right? So we you know, can work long hours into the night with bright blue light, and our body is going to be a little bit thrown from that, which is why when we talk about the well building standard, we want to kind of get back to creating systems that work with our body the way it was essentially designed to work. So on the daylighting side, so this is another part of when we talk about light, is access to daylight and also exterior views, very important, right? So there's a lot of surveys that have been done as far as trying to get a sense of how people prioritize natural light, just to get a sense of why that is. So access to natural light is going to increase, work has increased by 15% for those people who had window views when we talk about productivity. 50% of doctors value natural light, 42% of practitioners, 70% of psychologists and psychiatrists, and also 50% of HR executives, which is interesting in the business realm, consider natural light and external views when they look for workplace locations. So making sure that we have access to see the natural world outside of our office or our home is something that is definitely prized and also generates results as well when we talk about productivity. So what does WELL think of when they think about the light concept? So what are the goals overall? So it's just going to say, here are some illumination guidelines. So we want to make sure, A, we're going to minimize the disruption to your body's circadian system. And then B, we want to make sure that you can actually enhance productivity and give you visual acuity. So the ability to really distinguish and read easily without straining your eyes. That's all going to be part of the WELL light concept. And it's going to require specialized lighting systems to increase that alertness, enhance occupant experience, and promote sleep, presumably promoting sleep in the evening hours, not promoting sleep at noon when we're supposed to be our most productive. But how do we get there? It's going to be kind of what we talked about. So circadian design, daylight, glare control is a big one. So having the sun come directly into your eyes is not an ideal situation for productivity. Color quality, we'll talk a little bit about that when it comes to lighting. Activity-based lighting levels and contrast ratios, and then visual acuity, again, the ability to really easily read things without straining your eyes. So we try to figure out how does WELL come up with requirements that speak to all of these high-level strategies. And this is where we get the precondition versus optimization breakdown, right? So the preconditions that you're going to need to have to even achieve that silver status is going to be visual lighting design, circadian lighting design, glare control, and then solar glare control. So glare control both from the artificial lighting inside the electric light, but also from the outside. Then we get into kind of the fun stuff, the optimizations, and this is where it gets pretty advanced, pretty technical, but using technology, we're able to achieve a lot of these things in a truly automated fashion, right? So some of these features are only going to have one part, some of them may have 3 parts, and we're going to go over each of these features to take a look at how we get there and how we achieve certification. So the first thing is visual lighting design. So we want to make sure that the workers have proper light levels. How do we do that? We want to make sure that there's at least 20-foot candles at a workstation at the height of the workstation, so not measuring at the floor, but measuring where the desk is. We're also going to want to make sure that there's no greater than 500 square feet of open area for the control zones when we start talking about controlling the lighting. And if the lighting is less than 300 lux or 28-foot candles, we want to give task lighting. So task lighting, like in this photo here, could just be a desk lamp, right? It could be a tight down light that's focused on a particular workstation, depending on how you want to set it up. How do we verify this? It's going to be a letter of assurance from an architect, policy document, and then actual spot measurement as well. Okay, so making sure that everybody has proper light levels and nobody's, again, strained there. Additionally, we want to make sure that we maintain a balance to prevent eye strain in general. So we want to maintain contrast ratios between the main rooms and the ancillary spaces of 10 to 1. And we talk about the contrast ratio, we're really looking at how bright is the stairwell versus how bright is the main office area and so forth, right? So that ratio. Contrast between task surfaces and adjacent surfaces of 3 to 1, and then maintain brightness contrast ratios between task and remote surfaces of 10 to 1, and then also maintaining variety while minimizing dark spots and glare. We don't want to have a bunch of hot spots and dark spots all over, let's say, a ceiling or a desk, right? We want to make sure that everything is going to be comfortable and minimize that kind of variation. So we can't have the ceiling be 10 times greater or lesser in terms of its light output or reflected value in one area versus another. It should be a relatively even pool of light. When we talk about circadian lighting designs, and this is when we get into some of the biological stuff, which is pretty interesting, and there's a ton of really cool case studies on this as well. So we want to support circadian health and set up a minimum threshold for daytime light intensity. So what do we need to hit is one of these 2 requirements at least. At least 75% of the workstations should be, we'll talk about EML as a measurement, but at least 25% of the workstation should have the equivalent melanopic lux, which is what EML stands for, between 9 a.m. and noon. And then for workstations with at least 150 EML, we're going to use the recommendations for each station from IES. So again, same thing, we just need a letter of assurance from an architect, and then there's going to be an actual spot measurement as well. So, all light can affect your circadian rhythm essentially, but because people spend most of their time indoors, if you do have insufficient illumination or if there's, improper lighting design, you can actually cause a drift in that circadian phase. And if that's paired to bad light exposure, inappropriate light exposure at night, you're going to end up potentially, let's say you have trouble sleeping and things like that, right? So we want to make sure that people, again, are comfortable during the day and can kind of ease into their evening when they get home. So we're going to have to do kind of these calculations to make sure that that's going to be adequate and that those measurements will be hit. So what is EML? So it's going to be your measured lux, which we talked about earlier, multiplied by the ratio that signifies how active that light source is. So blue light, you'll hear a lot about, blue light blocking glasses, and your shifting phone is going to be reducing blue light and so forth. Blue light is going to be typically more biologically active. People look into the idea of like cortisol production and kind of be anti-melatonin in some ways, right? And we get that EML by looking at the lux level and then multiplying it by that ratio. So when we talk about this, it's important to just get a sense of what is the correlated color temperature, or the CCT, of the lighting. And so obviously as we get towards the bluer light, it's going to be a higher color temperature, a higher degree Kelvin, and that warm kind of candle light is going to be down maybe 1,000, 1,500, 1,800 Kelvin. So there's a few ways we can then take this into account, right? We can do 2 things. We can either put a cooler color temperature fixture with a much higher ratio, and that'll use less energy, but the drawback is that you may disrupt circadian rhythms because we're cranking out blue light, let's say, right? So it may be biologically disruptive, even with a dimmer. A better solution is going to be using a warm fixture, right? So a warm CCT, more comfortable in the let's say 3,000, 2,700, whatever it is. But because it has a low ratio, if it's bright enough, it'll still hit those requirements. But then the drawback is going to be you're using more energy. Again, dimming saves energy even with LEDs. So if we're looking at being energy conscious and sustainable, the best solution is probably not to just crank a very high level of output from your lighting. The best solution, which is kind of really where the industry has gone, is what we call tunable white fixtures, which can automatically adjust their color temperature and light intensity throughout the day. So you can get cooler light in the morning, and then automatically some of these systems can transition to warmer and dimmer output in the late afternoon and evening. This is the best situation for several reasons. I mean, in a lot of ways, it's mimicking what natural light does. So we don't have the disruption of the circadian cycle. And then also, it's saving energy as well because it's giving you the right light temperature at the right intensity at the right time of day. The drawback is going to be that these typically cost more upfront. But again, when we look at savings and productivity and human capital in the long run, it's by far the best solution that exists today on the market. So that was a little bit about circadian. The other thing that is called out in the requirements is glare control. So we want to make sure that people aren't going to be looking directly into the light sources themselves. That is not comfortable for anybody, whether it's at home, the office, or anywhere. You don't want to be looking directly into a light bulb or a fixture, right? We want to have some kind of control of the glare. So how do we do that? We want to make sure that we have that we're shielding at certain angles, right? So if you're, we'll look at a diagram of this, but you don't have to shield if it's less than 20,000 candelas per square meter off a reflected surface, but depending on the angle that you're looking at, you want to make sure that there's some shielding there. There are some accessories you can put on the lights, like a hex louver or a baffle or things like this that can or a snoot, let's say, onto let's say track lighting, that can give you angled shielding of glare. So you're not, unless you're looking at a very specific angle, you're not going to actually see the source of light. You're just going to see the light that's emitted from that source. So it's important to just, again, take into account glare and minimize that eye strain. And same thing, it's verified from a letter of assurance from an architect. So this is kind of the diagram of how that breaks down. Is we want to make sure that the overhead glare zone, which you see there in that kind of shaded area, is going to be minimized, right? We don't want to have a large glare zone. So if your seating area is more than, if the luminaire is more than 53 degrees above the center of the view, above that horizontal line, you're going to want to have luminance less than 8,000 candelas per square meter. So again, just being in the space and taking into account the fact that we want to minimize glare is going to be key for meeting this well standard as well. Interior glare with electric light is only one concept though. So we do have the solar glare facet as well. So we want to avoid glare from the sun, which means daylight control, which means natural daylight control. So we're going to have any kind of view window. So if there's glazing less than 7 feet above the floor, you want to provide one of these several things. So controllable or automatic window shades and blinds, an external shading system, or you can have that electrochromic glass, which will actually kind of tint and get more and more opaque or transparent depending on how much light is entering the space. So pretty cool technology there as well, but automatic shading systems can actually take into account, okay, what side of the building is the spacing? Is it west, east? What time of day is it? Where is this building located? And you can really enter all these calculations in the software, and they can automatically realize, okay, the sun's about to be shining directly through this window. Let's drop the shades down a little bit. And all this stuff can be programmed to kind of happen without the occupants having to get up, or the homeowner or whoever having to get up and actually do anything manually. It's all going to happen behind the scenes, which is really, when we talk about a smart, well-designed building, that's key, right? Making this stuff kind of automatic. So again, a few different ways to get there as far as minimizing solar glare. So the other thing is, we don't want to completely black out the windows, right? So we want natural light. We talked about the importance of that earlier. So how do we get that while protecting against glare? So you can actually have an intent here. We want to have the daylight come in while controlling the glare. So we can do this again through automatic shading systems, electrochromic glass, micro mirror film, light shelves. So there's several ways to get to this, but again, the key here is we want to find a happy medium between glare bombs of windows where you're getting the sun directly into your eyes, but also allow natural light into the space. And these are all kind of preconditions, right? These are those mandatory things we have to hit to even achieve that silver status. So how should a workspace be designed? We want to reduce glare. If you have a screen, you don't want to have your screen directly facing, a window. It should be kind of at a certain angle, so you're not going to be looking into your screen and into the sun at the same time. You can't aim your overhead luminaires. You don't want to aim those directly at computer screens for similar sort of reasons. So there's a really good kind of guide out there that tells you how to design a space like this to minimize the glare. Getting back into light, when we talked about the circadian light and we talked about good light quality, we were talking about CCT, right? So the color temperature, the correlated color temperature, which is measured in those Kelvin degrees. Another thing which has to come about as a result of us moving away from incandescent and halogen sources to things like fluorescence and ultimately LEDs is the actual quality of the light, the color quality. So we talk about color rendering index. I'm sure many of you have heard of or are working with it daily, but the CRI level, right? So we moved to fluorescence was the first thing we did after incandescence because of the energy efficiency, but fluorescence put off a pretty terrible quality light. I think we've all experienced that anytime you're in a space or, specifically like a bathroom looking into a mirror and you're standing underneath some fluorescent lighting, you're going to look blue and pale and sickly, and it's not great. LEDs have done a much better job of replicating light. So this is actually measured. So we can measure how poor quality or how strong and accurate the light is. So we need there's a requirement for an optimization, if you wanted to hit that optimization for lighting, that your color rendering index has to be 80 or higher. But the R9 value, and we say the R9 value, we're talking about the red value specifically as it relates to things like rendering skin tones, right? That has to be specially called out and more accurate as well. So 100 is going to be your perfectly accurate kind of true incandescent kind of light accurate. 90 is quite good in the industry. It's pretty much imperceptible between the 90 and 100, if you can get to 95 CRI and so forth. But again, the important thing is that R9 value, again, that red value is going to be at least 50 or higher. And we can talk about how to achieve that. But just, again, as far as making sure the space is going to make people feel good and look good, it's going to be important to have a high CRI for your lighting. Reflectivity of the surface as well. So we want to make sure enough light is going to reach the eye without increasing energy consumption and glare. So ceilings are going to have an LRV, so a light reflectance value of 0.8 or more for 80% of the area, of the surface area. Walls are going to be 70% or more, should have a 0.7 LRV. And then furniture systems, so your desks and so forth, are going to have 0.5% LRV minimum, or for 50% of the surface area. So we want to make sure that we're not filling the space with dark ceiling, dark paint, dark furniture, because what that's going to do is absorb more light than it reflects, essentially. And what we want to do to minimize or maximize our energy savings and our light in the space is going to be having reflective surfaces. So you'll see that LRV value obviously called out on most things that you'll be putting into the space. So just, again, take a look to make sure that you're going to hit those reflectance values that we do need for certification. Automated shading and dimming, we talked about when it came to glare, but this is actually an optimization in its own category, is going to be having an automated sunlight control. So if you can have an automated shading system, controls glare and reduces energy consumption without disrupting the occupants. So it's going to happen automatically. For any windows larger than 6 square feet at a workstation or a seating area, you want to have shading devices that automatically engage to prevent glare. Again, we want to make sure that this is going to happen seamlessly behind the scenes. And, with new technology and systems out there, you can get to that point where this is going to be programmed essentially to minimize glare and improve energy efficiency. Similar sort of thing when we talk about the electric light, so responsive light control. So if the room is unoccupied, we want to make sure the lighting is going to dim or turn off. You can do this with things like sensors, timers, and so forth, right? So automated controls that reduce output based on occupancy and daylight availability. So if we have a ton of light coming through these windows here, we don't necessarily need to have a ton of electric light, right? So if we have a lot of natural light, we can actually save a lot of energy and actually reduce overhead glare by dimming down or turning off that electric light. Non-decorative lighting is going to dim in the presence of daylight, right? So that's called out specifically. If you have a decorative fixture or something and it's an accent piece, you know, you can keep that in there and keep it lit, but making sure that again, we're harmonizing the outside and the inside by working together in a truly intelligent sort of system. Another thing we want to look at is what we call feature 61. So it's the right to light. So making sure that people have adequate levels of sunlight. And so putting desks and tables and workstations near windows with natural light, right? So, so there's a few different ways we can do that. So part one is we're going to have at least 75% of the area should be within 25 feet of the window. And part two is going to be, you know, 75% of workstations and 95 are within 25 feet, and 95% are within 41 feet of an atrium or a window with views to the outside. So this can be verified just from drawings or and a spot check as well. But making sure people are not kind of, people seem like movie Office Space. They only be buried in the basement with a red stapler with no access to sunlight for years, right? That's not ideal. We want to make sure people are near windows. One of the cool things that can happen with technology now is because we can replicate, there are systems that can replicate natural light. By having the natural light match up with the electric light on the inside, you can create even more of this kind of seamless connection between the outside and the inside. So technology is enabling us to really extend in that daylight as well, but making sure for well standards that we at least have people near the windows is going to be key. Sunlight exposure, right? So to support circadian and psychological health, we want to set thresholds for indoor sunlight exposure. So talk about daylight autonomy, achieving for at least 55% of the occupied space. So what that means is that 55% of the space is going to receive at least 300 lux of sunlight for at least 50% of operating hours each year. So again, we get really into the weeds with these metrics, but that's what we're talking about there, is that a good chunk of the space is going to be receiving an adequate amount of sunlight, and that can actually be measured and quantified. Annual sunlight exposure is going to be achieved for no more than 10% of the occupied space. So in other words, no more than 10% of the area can receive more than 1,000 lux for 250 hours per year. So you can't have more than 10% of your space that's just directly getting baked with an absurd amount of sun as far as natural light. And then automated shades can actually expand useful daylight. It's going to increase the daylight autonomy and comply with LEED's daylight credit as an alternative provided for 90% of the occupied floor area if it complies with the spatial daylight autonomy thresholds. So what is the concept of daylight autonomy? It's going to be a concept that evaluates the percentage of the workspace area where a predefined set of lighting requirements are met or exceeded. So usually related to glare potential, amount of the daylight availability, or both. So it's just worth looking at the photometrics and getting a sense of how much light is coming into the space. Daylight, fenestration. So another feature when we talk about daylighting, right? We want to balance the energy performance, the thermal comfort, and the access to quality daylight. That's kind of the harmony and the sweet spot we're trying to find. So, you know, making sure that the window to wall ratio is between 20 and 60% on the external elevations. Percentages greater than 40% are going to require some kind of external shading or opacity glazing to control between, you know, N1 heat gain and glare. We haven't talked a ton about heat and HVAC costs and so forth, but, you know, protecting the inside from glare also can help protect it from being baked in the sun in the summer and keeping your, you know, AC system going in the winter and so forth. Between 40 and 60% of the window area should be at least 7 feet above the floor. So again, it can easily be verified with drawings and a spot check. And this is another one of those optimizations for lighting, not a precondition. Additionally, we look at things like, you know, the VT of the glazing itself. So 60% or more if it's over 6 feet from the floor, and then locating if it's 7 feet or below. It also has to have that VT of 50% or more. Uniform color transmittance, so all windows used for daylighting have visible light transmittance of wavelengths between 400 and 650 nanometer, and it doesn't vary more by a factor of 2. So again, super technical, super in the weeds with a lot of this stuff. but it's all been kind of quantified and is because of that, it's easy to hit and understand kind of where we should be when we start to design a system and design a building. The other thing which is kind of interesting is, in addition to the optimizations we just talked about for lighting, you can also earn what they call up to 5 innovation features. So you can go above and beyond the well requirements. You can really make your mark by saying, yes, we're going to hit 80% of these optimizations, we're going to hit all the preconditions, and then we're just going to really go overboard and make sure that we're going to go into the details of explaining what we've done in this particular space. So you can do that by hitting the following. So you go above and beyond well, you have an explanation of the health concern, how the strategy impacts health, and then the research that supports the strategy. So as long as you do all of these things, you can get to a point where you're going, again, above and beyond, and you're going to actually innovate. So what are some potential innovation features? So one is going to be educational outreach. So what does that sound like? Educational outreach would be like if we can put some plaques up, for instance, in the space, which talk about what's going on in the building. So projects have achieved educational innovations by they've created signage that highlights well features. They've developed educational outreach programs and distributed newsletters focused on health interventions in their buildings and communities. We had one project team who approached the challenge of educating. They put placards explaining the well concept throughout the space, and they enabled the employees to learn more about the impact of their office on their health and wellness. So again, going out of the way to educate people. We've had buildings that have done tours, so a well tour in the city, or if they want to have people visit, they can put some information on their website and so forth. So again, going above and beyond on the educational side of things, talk about what's happening, because it may be imperceptible to somebody who's in a really well-designed space, no pun intended, I guess pun intended kind of. You could have the ability to, educate people. They may not know what the lighting is doing, but if you go out of your way and you say, here's what's happening with the lighting, it's shifting in color temperature throughout the day to promote circadian rhythms and so forth, right? You can really educate people. And then also creating a better sleep environment with blackout shades combined with side channels to talk about how we want to block out any kind of light coming through the gaps, right? So there's ways we can talk about how to do that. Automatic circadian lighting with color tunable lights is, that's an innovation feature. That's something that's pretty new to the industry, the idea of these automatically adapting lighting systems that think about what people need as far as their color temperature and intensity throughout the day to promote, healthy living. So that's something which is worth talking about. The other thing is that, so this is, the pilot is no longer being tested, but the pilot is done, right? So Well V2 launched, I believe, in 2020. Got lost in some of the other news in 2020, but this was up there as one of the big changes. So one unified well for all different project types. So it's going to have 10 different concepts, or it does have 10 concepts instead of 7. It's going to have more flexible optimizations, and it's going to be point-based, kind of like LEED is, and then streamlined features and fewer preconditions. So this is, again, it's out now. It's going to consolidate previous iterations and pilots into this one big one for every type of project, right? So office, retail, education, et cetera, it's all going to be under this well standard. The 10 concepts that it's going to use, so you mentioned 10 instead of 7, air, water, nourishment, light, movement, thermal comfort, sound is included now, materials, so the materials used, mind, and community. They replaced comfort with thermal comfort and sound, and then they spun off materials from the air concept. So they also changed it. It was fitness, now it's called movement. So if you're taking notes at home. And then in flexible optimizations in version 2, they can get points for completing parts of a feature. So, in version 1, which we talked about, you had to complete every part of that optimization. In version 2, you can do parts of one of the optimizations and still get essentially partial credit for it. And who doesn't love partial credit? Version 2, again, like I said, it's known as a 10-point or a point system. 110 is going to be the maximum amount of points, like LEED. And then silver status is going to be 50 points, gold 60, and then platinum is 80. And projects must earn a minimum of 2 points per concept. So they can't get more than 12 points per concept. but they need at least 2. So you got to kind of spread out what you're doing as far as your certification, what you're trying to check as far as your boxes. And then fewer preconditions as well. So, glare control, for instance, now combines solar and electric. We talked about it as 2 separate. Now it's just glare control, which I think does make sense. And there's fewer mandatory preconditions. So, making it a little more flexible and a little easier to work with. So this is going to be kind of what it's going to, now we're moving to 2 preconditions for lighting, right? And then here's some of the other, not a ton has changed. So that's, as far as the optimizations, pretty similar. There's just been some things that have been combined. All right, so just to wrap here, just a little bit of a case study is the ASID Headquarters. So the American Society of Interior Designers is the oldest, largest, and only multidisciplinary professional organization for interior designers, design students, and manufacturers who support the profession. So this is going to be a photo here of their headquarters in DC here. What happened was that this is an 8,500 square foot office. The architect is Perkins and Will. The lighting design was by Benya Burnett. And it's, obviously it's their corporate headquarters. So their board of directors, along with their CEO, thought that we should be the workplace of the future when they built this. So a living laboratory that could prove exactly what's possible in office design. And the goal was to create a space that supported health, wellness, and the well-being of employees, which would improve the organization's productivity, engagement, and retention. So that's what they kind of set out to do with this space. And how do I get there is through visual lighting design, circadian optimized lighting, automated shading and dimming, daylight and mute, the full gamut here, electric light and glare control from solar, minimize the solar gain heat, and then also VOC reduction as far as the materials they use in the shading. How do they do that? Through a digitally addressable lighting control system, tunable white lighting fixtures, solar adaptive automated window shades, and then having those Green Guard Gold window shade fabrics. So what are the results of this implementation? So they achieved nearly all the light features that they went out to do. All of the employees have access to natural daylight. There's been a 9% reported increase in employee collaboration, 19% improvement in absenteeism, and then a lighting energy reduction of 78%, so about $7,600 a year saved because of the reduction in the energy bill because of these automated systems working together. And this is notable because this is actually the first in the world to be LEED Platinum and WELL Platinum. So how does, in detail, they had the lights that went to the appropriate level for each space to help with the visual lighting design. They also automatically adjust the light on the inside and the color temperature, which accounts now even for seasonal solar angles and changing weather conditions. They maximize the daylight. And then they have solar adaptive automated window shades, which meet the automated shade feature and the glare control feature. And then because the shades, again, are Green Guard Gold to help them get that air VOC reduction feature. They also got an innovation feature, which we talked about before, for educational outreach, which they're highlighting the key sustainability features of the system. And then again, the results have spoken for themselves, right? So they've gotten a lot of both energy savings plotted from the industry and are that world's first kind of double platinum building. So, in summary, the Building Standard version 1 and version 2 provides a model for designing, construction, and integrating health features into the built environment. Focuses on those 7 areas. Light is definitely one of those. And then again, the daylight control and electric light control can contribute to 15 of 105 features using things like dimming, automated window shading, color tuning, circadian lighting, glare control. Again, we can go ahead and cross out this bullet. Well, V2 is out now, and it's going to be that point-based system. And then light is still a key concept in version 2. If you want some more info, you can definitely go to the WELL Certified website. You can go to Lutron's website /WELL, wellcertified.com, the ASID case study you can find on there, both on our website and on asid.org. So I just want to say thank you for joining and tuning in. Definitely any questions, feel free to ask them. I saw some people typing some things in the chat box. And like I said, thank you again for joining, and appreciate the time.
Hey, thanks, Ben. Appreciate that. Got a couple questions for you to start off the conversation. Um, First of all, given that this is another international standard, does Well have any opinions on daylight savings time? I've heard a lot of that discussion in 2020, and I'm curious if there's any sort of initiative to make a statement on getting rid of it or keeping it or whatever.
I personally have feelings on daylight savings time. I'm not sure. As it gets dark out here at 4:30 or whatever a day. I don't know if they have made an official stance on it or not. I'd certainly be happy if they came on board with trying to give us a little bit more daylight. But I don't know. It's a good question, and can certainly look into it. But I haven't seen anything on my end as far as an official statement.
Okay. Um, the other thing I'm interested in, if we bring this back into residential, there was a slide in there. You said 20-foot candles for each worker. If I'm thinking about a home office, is there a practical way to measure that at home? I mean,
Yeah.
I have tools
Yep.
here,
Yeah.
but like, how would you do this?
Yeah, for sure. So, yeah, home offices. I mean, again, I'm on the residential is kind of my focus, and home offices obviously have taken off, and a lot of people are thinking about how to invest and create a true, productive office space. You can buy a pretty affordable light meter. I have seen phone apps that attempt to approximate light meters. I don't find them to be particularly accurate, but you can buy a light meter and just kind of hold it at the space. So if it's got a little light receiver on there, you put it on top of your table and take a reading, and that'll give you a reading of either foot candles or lux. And they're usually pretty accurate, and you can pick it up on Amazon or wherever for probably $20, something like that. So that's going to be the only way that I'm aware of to actually get a light reading is going to be to use a light meter, but they're pretty easy to use. So, but yeah, if you want, I mean, I think if it's your own home office or something, and you want to make sure you have adequate light, it's that those requirements are, the minimum requirements. I think in a average, if you were to take a meter reading, unless again you're in some kind of dark basement or something, I think you probably would exceed the requirements in a home office space, just because if you're trying to light it for comfort, you're probably already providing an adequate amount of light for yourself. But yeah, definitely, it's easy to just go ahead and take a quick reading and verify that.
So I don't have a red stapler, but I do have a gray stapler. What you said about that, I know it made me chuckle. I saw Deb chuckle too. I started out my career working for General Motors, and it was in Syracuse, New York, in a basement full of computers, big, huge IBM and VAX mainframes, in a raised floor environment with blue light fluorescence. So I still shudder when I think of that, how many hours we were in there, and you'd never know daylight or and whatnot. So when I built this building that we're in right now, I said to my wife and that, like, in the architect we were working with, that I did not want to spend, another 20 years staring at blank walls. I wanted some sort of daylight, and I didn't know about any of these other initiatives. So we put in 16 solar tubes, which are these skylights. And then so in my office, I've got a skylight with a tube up to the ceiling. What is your feeling on that as a way to address some of these requirements?
Skylighting?
Yeah, skylights like a solar tube.
Yeah, skylights are, yeah, it's nice in the sense that you're probably not going to get a ton of glare from them because they're overhead. And if it can provide, now I don't know, so are they essentially, we're talking about electric skylights, kind of, right?
No, let me see if I can show you. There.
Okay.
That's
yeah,
the ceiling
that's a
in my
great way
office.
The benefit of that is that you achieve a lot of when we talk about all the circadian stuff, right? Because it's going to be natural light. You don't have to worry about the electric light matching and shifting in color temperature. If all of your light is provided essentially by natural light for windows and skylights and so forth, you'll still hit the right color temperatures the right time of day because you're mimicking outside. I think it's definitely a viable solution, and it still gives people that feeling of getting natural light, which is what we're all kind of after. So I think that's a good kind of workaround for sure. Yeah, I think any kind of natural light access you can build into a space, whether it's overhead or on a side windows, definitely helps. I mean, I think the tunable lighting that's out there now that is this kind of full spectrum lighting that will mimic natural light is another really powerful tool. Obviously, I'm biased and partial in that because that's kind of where I spend most of my hours right now, and I just see the impact of it. It's almost something you can feel when you walk into a space if the lighting on the inside is too warm. And this is even outside of home offices, just homes in general, right? You may want to cook your dinner by the cooler the color temperature. So if it's 4,000 Kelvin, it's going to be much easier to see. Your visual acuity will be up. It's like great for food prep. But then if you want to turn that room into a dining area, or you want to move into the next phase of eating or relaxing or whatever, 4,000 Kelvin is completely inadequate for that. It's going to be way too cool, way too blue. And now, for the first time, because of LEDs and technology out there, you're able to change that light from the same fixture can be 4,000 Kelvin, and then it can be 2,200 Kelvin when you're dining or something. And that's something that we could never even achieve that broad of a range with incandescence. It's really the first time that electric light has surpassed kind of the Edison sort of, original invention where full blast incandescent maybe puts out 3,000 Kelvin and then you can dim it down to a really nice warm level. But the challenge was you could never get that super cool light out of an incandescent. And then when you got to fluorescents and LEDs, you could never get the super warm light and the super cool light. But now we have the best of both worlds where you can get, some of the solutions out there. You can get a range from, 1,800 Kelvin to 10,000 Kelvin is really what I work with. That's enough of a variety to give you whatever you need for the right time of day. So in addition to things like natural lighting, because in that room with your skylight, as soon as the sun goes down, which is probably 4 p.m. this time of year, the skylight's not going to be providing much, but you probably still want to work until at least 4:30, I'm assuming. So in order to get there, you want to make sure you have adequate electric light as well, and you don't want to have, super warm light kind of glow.
After living with it for a few years, I did notice, when it's raining, which happens here often, it's dark. You can see cloud cover and some movement, but it's really mostly just a light source, and it's not focused. You're not looking through it. You can't see the outside or anything. But it is comfortable, to have. But I did notice that, like during dark days, and I don't even mean at night or whatever. I'm just talking about a rainy, dark day. It would be dark, So
yeah.
I think your response of being able to tune it and then control it, regardless of what's literally happening with the weather, is probably a better answer if I were to do that all over again,
Yeah, because the other thing is, like, if the sun is directly overhead of that light, let's say around noon or something, that could potentially be too harsh as well if it's not controlled with the shading system. And putting a shade on a skylight is, it's definitely doable, and that's where automated shades really come into play. But you could have potentially too much light, and you saw some of these requirements also call out too much direct sunlight as being an issue.
Glare bomb thing. Yeah.
Yep.
I have a question, Ben. This is Deb. I'm wondering if I know I've seen a lot of designers, especially in condos along the ocean or along water, where they use a wall of mirrors to enhance that natural light. And does that affect the WELL buildings certification when you use like mirrors for light?
Yeah, it's interesting. So mirrors, what they would do, obviously, if they're reflecting light, they would increase when you go to take those measurements, like I was talking about with Jeff with the light meter, your readings would be higher without having to really add any electric light, which is nice. So in that sense, from an energy efficiency standpoint, you could potentially get more light onto a surface by using mirrors. There's nothing that I'm aware of that's called out specifically that says that, like, mirrors reflecting natural views and natural light count as natural light. It's a very good question, though. There may be a carve out for that in the weeds of the details that, maybe if you have a mirrored wall reflecting a wall of windows, maybe that, in other words, if employees are sitting next to the mirror and they're more than whatever the measurement was away from the window, but they're sitting next to a mirror that looks at the window, does that count? I'm not 100% on that. Yeah, it's interesting. It would be kind of a good workaround if that was the case, but I am not sure. That's actually quite a good question. Unfortunately, don't have the answer for you.
No, I thought you answered it pretty well. Thank you, Ben.
Yep.
So one last question here. If anyone has anything, please put it in the chat. Have you noticed any of these standards making it into like computer monitors or laptops, the type of and quality of light that they put out, which are typically blue light intensive? And I've heard people wear blue light glasses and this and that, but those of us that stare at screens for the majority of the day, I mean, I'm just kind of wondering, can you make an investment in a monitor that would actually help you?
So I believe the answer is yes. One thing which is I called out the phones, and I try to be manufacturer agnostic, but I think at this point, everyone who makes a smartphone, the two major operating systems, both have the equivalent of night shift in there. And the same thing goes for computers, right? So if you go to your, let's say it's a Windows or a Apple PC, in the display settings, you will see something called night light in Windows.
Yeah, or dark mode,
night
right?
Light. So dark mode will help with your eye strain by making everything dark, but you also have night light and night shifts, right? So those are the names of the two of them. So you can have it automatically go on approximating when sunset is or at a particular time of night. And what that's going to do is going to shift the colors on your monitor to be warmer in the same way that your phone will do that. And that's part of the newest operating systems as well. So I don't know if it's as much baked into the monitor itself as it is the OS that you're using. But you can definitely do that, and I would recommend turning that on. Again, it's right in your display settings of whatever computer you're using. It's pretty intuitive and easy to set up, but that will accomplish what you're looking for, where it'll shift the color temperature to be warmer at night, and it's going to emit less.
I'm gonna look for that. I mean, I tend to put dark mode on everything from the touchscreen in my car to my phone and PC apps, but I didn't realize that they had it at the sort of the video driver level, if you will, where it changes throughout the day. So I'm definitely going to look at that. That's a good tip. Thanks so much for that. Well, it looks like we're at noon. I don't see any other chat questions coming in, so I think this is a good place to end it. Thank you very much for the informative presentation, and Deb, thank you again for your expertise. I appreciate all your time, and thanks everyone for attending, and we'll see you next Wednesday.